Welcome back to our organic chemistry journey. This is the fourth video in our series on organic reactions. Today we're diving deep into the fascinating world of ester hydrolysis. Get ready to discover what emerges from this reaction, and we'll break down and explain the specific conditions that make it all happen. Hold on to your conical flasks and data booklets, and let's jump in. Esters are fascinating organic compounds. You can see their functional group here. They start with a hydrocarbon chain ending in a carbonyl carbon. This is attached to another oxygen which links to another carbon chain. Our little friend here is called ethyl propanoate. Esters bring the fragrances we love, and they're not big fans of dissolving. These two features can be used to identify esters when you find them in the lab. As you can see, esters have parts. You can break them down into an alkyl group, like the ethyl here, and a carbonyl containing group, the propanoate here. Speaking about breaking down esters, this is basically what ester hydrolysis is. In hydrolysis, we use water to break down an ester into its two parts. When this happens, it yields an alcohol and a carboxylic acid. Hydrolysis is an endothermic reversible process. Consequently, the yield can be maximised by increasing the temperature through heating. This process does not occur spontaneously, but instead needs to be catalysed. There are two approaches here, the acid catalysed and the base catalysed methods. These produce similar but slightly different products, as we will now discuss. In ester hydrolysis, we need to add sulfuric acid as a chemical helper. It runs the show, helping the water molecule break up the ester to create two new chemicals. The water splits and gives the OH group to the alkyl group, making an alcohol. The remaining hydrogen from the water protonates the carboxylate group, forming a carboxylic acid. The example here shows the acidic hydrolysis of methyl propanoate. When the acidified reactants are combined together and heated to a moderate temperature, this reaction occurs, forming methanol and propanoic acid. Hydrolysis can be completed under basic conditions. The base used is often sodium hydroxide, but other soluble metal hydroxides could be used. In this chemical transformation, an ester such as ethyl butanoate reacts with the dissolved sodium hydroxide, leading to the formation of an alcohol, in this case ethanol. This is the same as the acidic method. The difference is that we obtain the carboxylate ion, butanoate, instead of the carboxylic acid. If it is wanted, the carboxylate ion can be transformed into the carboxylic acid through the addition of a dilute acid. Given these two methods, you might want to know which is most commonly used and when. Acid catalysed hydrolysis is often used in the laboratory and in industry. It is typically faster than base hydrolysis, and hence it's handy. On the other hand, base catalysed hydrolysis is used specifically in the production of soaps. This process is called saponification. It takes a triglyceride, which, as you can see here, contains 3 ester bonds. These are broken by base hydrolysis, yielding a glycerol molecule and 3 long-chained carboxylate ions. These carboxylate ions are soap molecules. Let's assess our understanding with questions sourced from Learn with Longman on Teachers Pay Teachers. This platform provides quality educational resources. Explore the link in the description to access educational materials. Immerse yourself in this extensive guide encompassing all aspects of organic reactions. In our first question, your task is to write the balanced equation for 2 hydrolysis reactions: acidic hydrolysis of ethyl methanoate and basic hydrolysis for propylbutanoate. Take 4 minutes to work on this, and when you're ready, come back for the answers. Welcome back. Let's go over the marking guide. Double check that you did the following correctly. Are the reactants drawn correctly? Are the products drawn correctly? Did you include the acidic catalyst? Did you include reversible arrows? Each of these are important if you want to achieve full marks. All right, time for another challenge. This is part of an extended calculation, and the rest, of course, can be found on my Teachers Pay Teachers. Given a hydrolysis reaction equation, which is only 60% efficient, and with a starting mass of 1.26 kilograms of the ester, we are asked to determine the final volume of alcohol which is formed. Take into account the density of the alcohol as you do this. It's a 6-mark question, so use that many minutes and give it a shot. Welcome back. Let's go over the marking guide. Check your solution against these points. Did you correctly calculate molar masses? Did you calculate moles of ester and then use stoichiometry, considering the 67% yield, to convert this into moles of alcohol? Did you then convert this into a mass and use the density formula to determine the volume? If you've covered all these bases, well done. These are skills you can confidently apply in exams anytime you need. My goal on this channel is to simplify your schooling experience. If you found our breakdown of this topic helpful, please show your support by liking and subscribing. Stay tuned for more valuable content to come.